So with the photoelectric effect, the toughest thing to sort of get your head around is this idea of models to describe what's happening with the photoelectric effect. So what the photoelectric effect is we shoot light at a metal plate, and when we do that, electrons fly off. That's all the photoelectric effect is. So what we want with physics is we want a model to explain what's happening with the photoelectric effect. So there's two models that we have right now. We have the classical wave model, and then we have this quantum particle model. And we want to see what our predictions would be with both models. So I'm going to start with the wave model. So two things that I can manipulate are wave intensity. So intensity is how hard I make this wave go, how big the amplitude of the wave is, right? So I can have a huge intensity, or I can just have a low intensity. And the other thing that I can manipulate is a frequency. So how many waves per second? So I can have a low frequency, or I can have a high frequency. Those are my two things that I can manipulate. So to model electrons, I have electrons inside my metal plate here, and these are going to be my tennis balls. So what you can predict now and what you can see, well, let's see what happens if I have a high intensity. If I have a high intensity, you can see, oh no, my electron hit my phone. If I have a high intensity, you can see how those electrons fly off with a big speed, and we get electrons to fly off very quickly. That's what we see, right? And if we have a lower intensity, if I just do a little bit of an intensity, they still fly off, but my electrons fly off at a much lower speed. So that's what my model predicts, and my analogy keeps on knocking over my phone. So now I can change frequency, right? If I have a very low frequency, what we're going to see is it takes longer for those electrons to fly off. There it goes. But they still fly off, right? And then if I have a higher frequency, what you can see is those electrons are going to fly off much quicker. Right? Now they're off. Okay, and then some electrons are harder to get to leave because they're better bound to the metal. So now we have a harder one to fly off, right? And if I have a big intensity, well, I still can get that electron to fly off. Come on, there we go. So I can still get that electron to fly off, but it's just a little bit harder, right? But no matter what I do, I always get electrons to leave, and that's what the classical wave model predicts. No matter what light I shoot at it, whether it's low frequency like radio waves or high frequency like ultraviolet waves, it's still gonna fly off, okay? So now let's switch to the particle model. So with the particle model, we have our electrons on our plate, right? And I'm gonna represent the frequency, which is the energy, by the size of the ball. So I can have a high energy photon and I can have a low energy photon. So these electrons are relatively easy to get to leave my plate, right? So if I shoot a photon at it, I can get it to leave, right? And if I shoot a higher energy photon at it, I can get that electron to leave. But what we see with the particle model, the quantum model, is that if I shoot low energy, low frequency light at an electron that's difficult to leave, right? Nothing, right? I can't get that electron to leave. I swear that went in the garbage can. That's actually crazy. And if I shoot a higher energy at it, right, it still can't leave. So what I need is I need a photon with enough energy to actually get it to fly off. So that photon had enough energy to get that electron to leave. But what I'm doing is I'm shooting one photon at one electron, and I get that photon to fire off that electron. That's what our particle model is doing. So try to think of this when we're comparing the classical wave model compared to the quantum particle model. Okay, I hope that helps.